I'm going to now go ahead and work through the problems on this MATH136 test 1 review. So let's go ahead and get started. Number 1, the instructions are multiply and write in lowest terms. Typically, when you multiply two rational expressions, you can think of it as almost like one fraction, factors on the top, factors on the bottom. I just need to see if things cancel out. I have m squared on the top and m on the bottom, so I can cancel out an m in the top and the bottom. 14 on the top and 7 here. That reduces down to 2 over 1. 10 over 15, I can divide both those by 5. Get 2 and 3. So by time you do all that, if I can keep it all straight, looks like (4m over 3). Another one here. Here I can factor first, and over here actually both. So I need to go and factor. Difference of squares here. X plus 3, x minus 3 over x. Let me just make this all one fraction. Factor out an x here, x plus 4 over x minus 3. Now I simply see if I have any identical factors, which I can cancel on the top and the bottom. X minus 3, this x here, this x here. Looks like when I'm done, this is what I have, x plus 3 times x plus 4. Now the next problem is you're dividing two rational expressions. Remember how you learned how to divide fractions is you write the first fraction and then you multiply by the reciprocal of the second fraction. Now, once again, because they're multiplying fractions, I could think of this as sort of all one fraction. Looks like in the top, I have z to the 7th. In the bottom, I have z to the 7th. So those all cancel out. So basically, it's 45 over 9. So in this case, it reduces down to 5. There actually aren't any z's left. Sometimes that happens. It's pretty rare, but sometimes all the variables cancel out. Here's another division problem. This is one we need to factor before we do anything. So here's our trinomial. And it should be x minus 2 times x minus 1 over x plus 3 times x plus 1. Then you multiply by the reciprocal, x plus 1 over x minus 1. Now we see if we can cancel out anything from the top and the bottom. X plus 1, x plus 1, x minus 1, x minus 1. Looks like when we're all done, we have x minus 2 over x plus 3. All right, then we get to number 5. Now, gets a little messier because now we're going to add these two rational expressions together. So the procedure is factor and find the common denominator. So I have two denominators here. So the LCD would be x times x minus 4. So I have to take both these fractions, see if I have room to do it here. And I have to convert both of these fractions to have the lowest common denominator. So in other words, this first fraction, 3 over x minus 4, needs the new denominator, the lowest common denominator should be x times x minus 4. To go from x minus 4 to x times x minus 3, you multiply by x. But of course, you have to multiply top and the bottom by the same thing, so multiply the top by x. So when you get done with that, the first fraction becomes 3x over x times x minus 4 plus, now the second fraction, once again, my denominator needs to be x times x minus 4. To get from x to x times x minus 4, I have to multiply top and the bottom by x minus 4. So the second fraction now becomes 2 times x minus 4 over x times x minus 4. Now you notice these two fractions have the same denominators. Now we can actually add them. So the common denominator is going to be x times x minus 4. In the numerators, you add 3x plus 2 times x minus 4. It's going to multiply out this parentheses. So this is going to be 2x minus 8. Three x plus 2x looks like 5x minus 8 over x times x minus 4. Next one, for adding 3 rational terms, or actually subtracting. First thing you have to do is to find the LCD. First of all, you have to factor. This is going to be x plus 1 times x minus 1. Looks like the LCD is going to be x minus 1 times x plus 1. Now I have to take each of these 3 fractions and convert them. Let's see if I can squeeze it in here. This first fraction, you multiply top and the bottom by x plus 1. This first fraction becomes about 4x times x plus 1. Second fraction, need to multiply top and the bottom by x minus 1. So it's going to become 2 times x minus 1 over x minus 1, x plus 1. Hopefully you see this last, actually, subtract. This last term already has the LCD in the denominator. So now I can write the common denominator. In the top, let's multiply these out. So this is 4x squared plus 4x. Be careful now. So it's minus 2x. Then minus a negative 1, which is plus 1. And then minus 4. So hopefully, not many math errors. 4x squared plus 2x minus 3. Now I have the answers here, and doesn't look like what I have in the key. So let me see if I made a mistake. So this is how you do this. So of course, the key might be wrong. 4x times x plus 1, which is 4x squared, plus 4x. And then 2x, I'm subtracting 2x plus 2. Oh, I have a 1 here. 2x plus 2, and then minus 4. Don't know if that's going to matter. 4x squared plus 2x minus 2. Just to be sure, here's what you do when you're not sure. You go and rework it with plenty of room, not trying to squeeze things in. 4x over x minus 1 minus 2 over x plus 1 minus 4 Here's your original problem. I need to factor this third This is the difference of squares. Now my LCD is going to be x plus 1 times x minus 1. So for this first fraction, multiply the top and the bottom by x plus 1. 4x times x plus 1 over x plus 1, x minus 1. The second fraction, you multiply a top and a bottom by x minus 1. So minus 2 times x minus 1 over x plus 1, x minus 1. Then the third fraction already has the common denominator. So now you write the common denominator. I multiply these parentheses out. 4x squared plus 4x minus 2x minus a negative 2x, or minus a negative 2, just plus 2, minus 4. So now 4x squared plus 2x minus 2 over x plus 1 times x minus 1. So this is not the answer on the key, but I think the key might be wrong. When I'm done, I will confirm it, but as of now, that's the answer I'm going with. All right. Number 7, we have a complex fraction. First of all, you have to check and make sure you have one denominator over one denominator. I mean, one fraction over one fraction, which I do. Although I need to go ahead and I'm going to go ahead and factor this. So it's y plus 4 times y minus 4. Now, when you have a fraction, that's basically a division problem. So when you're dividing two fractions, I can take the top fraction and multiply it by the reciprocal of the bottom fraction. So it's y plus 4, y minus 4 over 12. So the y minus 4 is canceled out. This reduces down to, so I hope the key has y plus 4 over 2. And it does. So here's one more. Now this one's going to take a little extra work because I don't have one fraction over one fraction. So I have to go off 6 plus 1x. I need to combine that into one fraction. So that's the same thing as 6x over x plus 1 over x. 6x plus 1 over x. So the numerator now becomes 6x plus 1 over x. The denominator, have to do the same thing, have to combine it into one term. This is going to be 7x over x minus 3 over x. 7x minus 3 over x. Now that I have one fraction over one fraction, now I can write the top fraction and multiply it by the reciprocal of the bottom fraction. It's like the x's cancel out. 6x plus 1 over 7x minus 3. That looks correct. So there's the first page. Now you turn the page. So far, everything we've done so far, it's been expressions, which we typically just simplified. Now we're trying to solve some equations. So here are these rational expressions. The steps you go through: first factor, then you find the lowest common denominator, and then you multiply both sides by the lowest common denominator. So when you do that, you end up clearing the fractions. So my denominators are x2 and 2x. Lowest common denominator is 2x. So let's see if I can squeeze it in here. So 2x times the left-hand side, 2x times the right-hand side. So when you do that 2x times 2 over x, the x's cancel, and you have with 2 times 2. And then 2x times negative 3 over 2, the 2's cancel. And you're left with minus 3x. And on the other side, the 2x's cancel. And you're left with 7. So that's why we say clear fractions, because the fractions are gone. Now if I want to solve for x, in other words, when it said solve this equation and x is my variable, it's basically saying, what does x equal? Subtract 4 from both sides. Divide both sides by negative 3. End up with x equals negative 1. Now, be careful. Anytime you start out solving an equation with rational expressions, when you get done, don't forget you got to check your answer. So is minus 1 going to cause a problem? No, it's not. Looks like the only issue we would have is if x equals 0. So it looks like this should be the solution. Ten looks pretty similar, although from the start, we need to factor this. And when you do that, looks to me like the lowest common denominator is going to be x plus 3 times x minus 3. So if we, left-hand side, we sort of group all this and we multiply by x plus 3, x minus 3. And this side we multiply by x plus 3 over x minus 3. So this x plus 3 times x minus 3 times 2 over x minus 3 looks like the x minus 3's cancel. So you have 2 times x plus 3. Then x plus 3 times x minus 3 times the second term, the x plus 3's cancel. And you have minus 3 times x minus 3. On the right-hand side, x plus 3, x minus 3 cancels with x plus 3, x minus 3, so you're just left with so 2x plus 6 minus 3x plus 9 . So this is 6 plus 9 is 15, and we're going to subtract it. Looks I'll end up with minus 3 over here, and 2x minus 3x is negative x. Looks like my solution is x equals 3. And that's not, oh, number 10. All right. You have to check though. I was getting ready to check. What happens when x equals 3? You put it back in the original equation. You get 3 minus 3, you get a number over 0. Even though the math said x equals 3, it's not a solution. because it's going to cause the denominator to be 0. Matter of fact, turns out for this problem, there's no solution. So that happens sometimes. For this one, let's go ahead and just do it down here. Things are getting pretty messy on those problems above. Solve this equation, x equals what? There's no factoring. Looks like the lowest common denominator is going to be x times 3x plus 1. So I can multiply both sides. X times 3x plus 1. X times 3x plus 1. So on the left-hand side, the x's cancel out. Left for 3x plus 1 minus 3x plus 1s cancel out. You're left with negative 6x. Right-hand side, 3x plus 1s cancel out. You're left with 2x. So this is negative 3x here. At the other side, it's 5x. If I didn't mess up, I'm saying my answer is 1/5. That's not a problem. Except, let me check my key again. See if I made another math error. I wrote the problem down wrong. That happens. So, you know, by this, you get 3x plus 1. And here you get 6x squared. Equals 2x. Give me everything on the left-hand side. 0 equals 6x squared. Minus x minus 1. So let's go and keep going and see if this thing factors at all. The product is negative 6. The sum is minus 1. Negative 3, 2. Minus 3x. So factor by grouping. So 2x minus 1. 3x plus 1. So solutions are going to be x equals 1/2 and minus 1/3. But the minus 1/3, if you plug it back into its equation, it's going to cause that denominator to be 0. So that is not an acceptable answer. 1/2 is okay. So the solution is x equals 1/2. All right. These are pretty messy. Now we're ready for number 12. Complex numbers, real and imaginary parts. First one, pretty straightforward. Going to add these two complex numbers. You add the real parts, which is 8. You add the imaginary parts, which is 7i. Here, we're multiplying two complex numbers. It's just like foiling. 2 times 6 is 12. 2 times 4i is 8i. 3i times 6 is 18i. 3i times 4i is plus 12i squared. I squared is -1, so we can think of this as minus 12. So 12 minus 12, the real part's actually 0. By the time it's all said and done, the answer is just 26i. Now here's a fraction, although fraction is really like division, so you can think of this as dividing two complex numbers. We cannot leave, not supposed to leave an I in the numerator, so you get rid of it by multiplying top and the bottom by the conjugate. What's in the bottom, right? The conjugate is the same two terms, just different sign. Now you can FOIL this, although there's a little shortcut where you square the first number minus, and you square the second term. Now on the top, I just have to do old-fashioned FOILing. 2 times 6 is 12. 2 times -4i is -8i. 3i times 6 is plus 18i. And then -12i squared. Now it's simplifying. First of all, I squared is like -1. So -1 here makes us plus 16. The denominator becomes 52. If I squared's a negative here. So -12 times -1 is positive 12. So it's like 24. Let's try and reduce this. Divide everything by 2. Of course, you're talking about complex numbers. They want it in the form a plus bi. So we need to split this up into 12 over 26 plus 5 over 26i. 12 over 26, if you divide by 2, 6/13 plus 5 over 26i. All right. Now I got a bunch of equations to solve. I think these are going to be quadratic equations. This, I can just use the square root property, right? If I take square root of both sides, you get x equals plus or minus 7. Here, it doesn't factor. I'll move it to the other side. Now, if I take the square root of both sides, now until just recently we would stop, but now we know the square root of negative 49 is plus or minus 7i. Now we can write the answer as a complex number. Here's one that I think might factor. X minus 4 times x minus 2 equals 0. And multiply together equal 8. And when you add them, they equal minus 6. Looks like the solutions are going to be 2 and 4. Here's one. I don't believe it factors. So our only choice is the quadratic equation. Just to remind you, it is negative b plus or minus b squared minus 4ac. Probably all seen it before. Looks like a is 3, b is 5, c is 1. So negative b, negative 5, plus or minus b squared minus 4 times a, which is 3, times c, which is 1, all over 2 times a. Negative 5 plus or minus, this is 25 minus 12. Negative 5 plus or minus square root of 13 over 6. And that is the solution. Another equation, looks like I'm going to once again use the quadratic formula. A is 3, B is 5, C is 3. So X equals negative B, negative 5, plus or minus. B squared is 25 minus 4 times A times C over 2A. This is negative 5 plus or minus. This is 12 times 3, 36, 25 minus 36. It's like negative 11. Now, up until recently, we would have just stopped because we realized you can't have a negative under the square root. However, now, since we have complex numbers, we could say negative 5 plus or minus I times square root of 11 over 6. And since it says a complex number, they don't like to leave it as one fraction, so negative 5, 6 plus or minus square root of 11 over 6 times I. All right, something different now. Equation that starts with a square root. Now, this is another one of those problems where when you find your solutions, you're not done until you check each solution and plug in your solution back into the original problem. So the way we do these problems, when you have a square root, you get it by itself on one side, which it already is. And then we need to get at this x, so we need to get rid of the square root. The way you get rid of a square root is to square it. So if I square both sides here, end up with 2x plus 6 equals 16. Subtract 6 from both sides. Looks like x equals 5. Now let's check and make sure that works. I got to plug 5 back into my original equation. So square root of 2 times 5 plus 6. Does that equal 4? This is 10 plus 6. 16 squared is 16 equals 4. Yes, it checks out. That is a solution. Here's another one. A little different. We have an extra x here. Let me do this one down here. What you want to do is you want to get the square root by itself on one side. So let's add the square root to both sides. So you end up with this. Now I need to get rid of the square root so I can square both sides. And now this is a quadratic equation. Let me go ahead and get everything on the left-hand side. Maybe this thing will factor. Looks like x minus 4 times x minus 2. So my proposed solutions are 2 and 4. Now I have to check each one of them out. Put back 2 back in the original equation. You have 2 minus 12 minus 8. Does that equal 0? So 12 minus 8 is 4. Square root of 4 is 2. 2 minus 2. Looks like that checks out. Let's try 4. 4 minus 4 times 6 is 24. Minus 8 is 16. I'm looking at the, oh yeah, it's number 22. All right, so checking out 4. 24 minus 8 is 16. Looks like they both check out. So 22, 2 solutions, 2 and 4. Another one. Looks like the radical's by itself. So let's square both sides. The left-hand side, you get 3 minus x. Right-hand side, you get x squared plus 6x plus 9. Let's get everything on the right-hand side. It's going to be plus 7x. You subtract 3. I think this factors into 6 times 1 is 6 plus 1. So therefore, the proposed solutions are minus 6 and minus 1. Now we have to check them out. Let's plug in -6 in the original equation. So it's 3 minus a -6. It's 3 plus 6. The square root of 3 plus 6 equals -6 plus 3. That is not a solution. If I look at -1, three plus 1 equals -1 plus 3 is 2. Square root of 3 plus 1 equals 2. Yes, it does. One solution of -1. All right. 24 now. Looks like we have some absolute value problems. All right, the way we solve these is get the absolute value by itself on one side, which it already is. Make sure the numbers is a positive number, which it is. If that's all true. Then we're going to break it up into two problems. First one is you drop the absolute value signs and you solve this. Let's add 1 to both sides. Second problem is you drop the absolute value signs and you make the number a negative. Looks like two solutions, x equals 2 and x equals -1. '25, another absolute value equation. First step is get the absolute value by itself on one side. So let's subtract 20 from both sides. Divide both sides by -4. Number is positive, break it into two problems, drop the absolute value signs, and you solve this. Over here, drop the absolute value signs, make the number negative. Looks like two solutions, x equals -2 and x equals 3. All right, solve the following inequalities. Absolute value inequality. First step is get the inequality by itself on one side. So let's add 6 to both sides. Divide both sides by 2. Now, since this number is positive, I'm going to break this up into two problems. First one, you drop the absolute value signs. And you solve the inequality. Add 1 to both sides. In a minute, I'm going to graph this. But let's go back now and do the other problem. So drop the absolute value signs, you flip inequality, and you make the number negative. So we're going to solve this. We're going to add 1 to both sides. So now I'm going to graph both of these. X greater than or equal to 4. And x less than or equal to -2. So this is a case where you have two distinct intervals. So for this case, the answer ends up being you have to union both these intervals. So this first one goes from -infinity to -2, and you union it with, oops, I need to have brackets. And you union it with 4 to infinity. All right, here's another one. Get the absolute value by itself. We'll add 6 to both sides. Divide both sides by 2. Since my number is positive, break it up into 2 problems. X minus 1, just drop the absolute value signs. Add 2 to both sides. The other problem, drop the absolute value signs. Flip the inequality. Make the number negative. Add 1 to both sides. So here, my 2 solutions, x less than 2, x greater than 0. So this is a case where the 2 graphs intersect. So therefore, the solution is just where they intersect. Solution is x equals the interval from 0 to 2. '28 looks like a pretty straightforward inequality. Goal is to get x by itself, so let's subtract 6 from both sides. If I want to get x by itself, I need to divide both sides by -2. Now you can do that, but remember, because you're dividing by a negative number, when you get all finished, you have to flip the inequality. So the solution is x greater than 5. If we were to graph that, looks like this. So therefore, the solution as an interval would be 5 to infinity. Here, we have a 2-sided inequality. So we got 3 parts to it. Our goal is to get x by itself in the middle. And whatever we have to do to get x by itself, we have to do the same thing to all 3 parts. In other words, I need to get rid of this -1. So I'm going to add 1 to the middle. But then I have to add 1 to the right side and add 1 to the left side. So end up with -2. In the middle is 2x. Now, if I want to get x by itself, I've got to divide all 3 parts by 2, -1. So I got x by itself. So you have x greater than or equal to -1 and x less than 5. Let's go ahead, graph these one at a time. By that I mean, let's do this part, x greater than or equal to -1. Here's -1. So that's a graph of that part. Graph of this part, x less than 5. Solution is where they intersect. So it's -1 with a bracket to 5 with a parenthesis. All right, 30. Now we have what we call a quadratic inequality. It's going to be a little bit of work involved here. First step is get everything on one side, x squared plus 3x plus 10 less than 0. What I'm going to do now is, first of all, I realize I'm looking for a solution for x, where when I plug in the value for x, this expression is going to be less than 0. Or you could think of it, solution has to be a negative number. That's what it means to be less than 0. I'm going to factor this. Now I'm going to find the zeros of x. Zeros of x basically means you could think of taking this expression and trying to solve it. Set it equal to 0. Those are called the zeros. These are values of x that would cause this expression to equal 0. So the zeros are going to be -5 and -2. Now, once you have the zeros, to make a little graph here, there's -5, there's -2. These become my boundary points, or sometimes I say my transition points. So I'd end up with 3 regions. In each of these regions, when you plug in the values of x, it's either going to be positive or negative. I don't know what it is right now. We're going to figure out in just a minute. And the way we're going to do that is we're going to create a sign chart. So I have 3 regions. I'm going to choose a test point or a value of x in each region. So in region 1, I need to choose something between -infinity and -5. How about -6? Region 2, something between -5 and -2, about -3. And region 3 is something between -2 and positive infinity, how about 0. Now, for each region, I'm going to take that value of x, plug it back into this expression, and then end up seeing whether the expression is positive or negative. That's all I care about. I don't really care about the number. I just want to know what the sign is. So for -6, if I put in -6 in this first parenthesis, it makes it negative. If I put in -6 in this parenthesis, it's negative. Now when you multiply 2 negatives, you get a positive. I now know that region 1 is a positive region. That means if I choose any value of x between -infinity and -5, I could choose -100, -10, -7, and I take that value of x and plug it into the expression. That expression is going to be a positive number. Now for region 2, if I plug in -3, -3 into this first parenthesis, it's positive. -3 into here, it's negative. You multiply positive times a negative. Region 2 is a negative region. Now, region 3, if I plug in 0, that's positive. 0, positive. 2 positives make a positive. Regions 3, positive. So now I've got my regions figured out. Now all I have to do is look at my initial problem. I'm looking for the values of x that cause this expression to be less than 0 or negative. Actually, there's only one region in here that will give me a negative number, and that's region 2. So the solution is going to be in the interval from -5 to -2. All right, here's another one. See what's going to happen here. Same thing. Now this one, it's already, everything's on the left-hand side. You got 0 over here. So this one, since it's greater than or equal to 0, we're looking for the values of x that make the expression positive or 0. Let's go and factor it. I think it's going to be x minus 7 times x plus 2. Now to find the zeros, basically, what are the values of x that causes either one of these parentheses to be 0? It's pretty clear it's going to be 7 and negative 2. So now, so go make a graph here, break it up into regions. So there are 3 regions. Let's find a test point in each region. For 1, I'll choose -3. For 2, I'll choose 0. For 3, I'll choose 8. Now we're going to see what the overall sign is. So for region 1, I plug -3 in here. This is negative. This is negative. 2 negatives make a positive. Region 2, I plug in 0. This is negative. This is positive. Negative times positive is negative. Region 2 is negative. Region 3, you plug in 8, you get a positive and a positive. Region 3 is positive. So what am I looking for? I'm looking for values of x that give me a positive number or 0. So it looks like it's going to be regions 1 and regions 3. So I have to union them together. So region 1 starts at negative infinity, goes to -2. Now I include the boundary point, since the solution can also be 0. Then it starts up again at 7, and I include 7, and then off to infinity. All right, now we got some story problems. These next couple are called work problems, where one person does a job by themselves, second person does a job by themselves. How long will it take them if they work together? So here, Sue can rake the leaves by herself in 4 hours, while it takes Sam 5 hours to rake the leaves by himself. How long if they're working together? Here's the equation for these work problems. It's a pretty straightforward equation. You put 1 over the time it takes the first person to do the job by themselves, that's T1, plus 1 over the time it takes the second person to do the job by themselves, that's T2, equals 1 over T sub T. This is the time if they work together. So for this problem, Sue is 4 hours. We'll put her time here. Sam's was 5 hours. We'll put his time here. And we'll just call this T. This will be the time when they're working together. So I need to solve this. I'm going to go ahead and clear the fractions. So I think the LCD is going to be like 20T. Multiply both sides by 20T. 20T times 1/4, 5T. 20T times 1/5, it's 4T. 20T times 1 over T is just 20. 9T equals 20. If I leave it as a fraction, the time to work together is 20 over 9 hours. Another work problem, but a little twist to it, because working with your cousin, you can refinish the table in 8 hours. So this is the together time. Working alone, your cousin can do it in 12 hours. How long would it take you to refinish the table working alone? So it's the same equation, except we'll call the cousins times T1, takes the cousin, well, let me get this sheet of paper. So they're going to use the same work equation. So for this problem, the cousins by themselves can do it in 12 hours. So I'll make that T sub 1. This T sub 2 is going to be the time it takes me to do it by myself, which I'm actually trying to figure out. So I'll leave that as the variable T. And they tell me how long it takes when they're working together, which is 8 hours. Not that much different than the last one. Matter of fact, I'm going to, once again, multiply both sides by the LCD to clear fractions and try and solve this. So that's 2t plus 24, right? 24t times 1 over t equals 3t. Subtract 2t from both sides. Looks like it would take 24 hours for me to do the job by myself. All right, another story problem, airplane flying with the wind and against the wind. The key here is to remember that distance equals rate times time. So normally I set up two equations, one with the wind, one against the wind. So let's see what information we have. A plane flies 420 miles with the wind and 340 miles against the wind in the same length of time. If the speed of the wind is 20 miles per hour, what is the speed of the plane in still air? So I'm going to let we'll call R sub A. Oh no, let's just do this. We'll let R be the airplane speed. We know that the wind speed is 20. So now I'm going to apply this equation when the plane's flying with the wind and against the wind. So what do I know? When he's flying with the wind, we know how far he flew. Yes, it says flew 420 miles with the wind. So 420 miles. R is the rate or the speed. What's the speed when he's flying with the wind? Well, what you do is you take the plane speed and you add to it the wind speed, because the wind is actually making you go faster. So R plus 20. Do we know the amount of time it took him when he was flying with the wind? We don't know that. We'll just call it T for now. Now against the wind, if I try and write out distance equals rate times time, do we know how far he flew against the wind? Yes, we're told 340 miles an hour. What do we say about when he's flying against the wind, well, it's the plane speed, and this time you subtract the wind speed because it's slowing you down. Now, do we know the time he was flying against the wind? We don't know it, although it does say with the wind and against the wind, it was the same length of time. So if I'm calling the time with the wind t, I can also call the time against the wind t. Now, what's interesting is if I take this first equation and I get t by itself, so I'll divide both sides by the parenthesis r plus 20. And I'll do the same thing to the second equation. I'll divide both sides by the parenthesis r minus 20. Now, the interesting thing is these times are the same. So what I can do is I can just set this equal to this. And when I do that, I have an equation with only one variable r. I can try and solve this. Now, in this case, if you remember, one little tricks, when you have two fractions equal to each other, you can do the old cross multiplication, right? So you would say 340 times r plus 20 equals 420 times r minus 20. Let's go and multiply out these parentheses. $340r, I get my calculator, 340 times 20. Don't want to mess up. 6,800. 420r, 420 times 20. 8,400. So let's do this. Let's subtract 340r from both sides. So I think I end up with 80r, and let's add 8,400 to both sides. If I divide both sides by 80, looks like the speed of the plane would be 190 miles per hour. All right, one more story problem. This one is actually the easiest one, number 35, because they actually give you the equation. The other story problems, I had to figure out the equation. So this is where a ball is thrown up in the air. Its distance in the air after t seconds is given by this equation. So S is like the height of the ball. T is like the time in seconds the ball has been flying in the air. Two questions. The first question, what will the height of the ball be after 2 seconds have passed? So if this is my equation, oh, hang on, let me take care of that. Here's my equation, minus 16t squared plus 128t. So we're basically saying if I plug in 2 seconds for t, what's the height going to be? So I plug in 2 for t, so it's 2 squared, plus 128 times 2. I grab my calculator. Actually, this is 4. 4 times negative 16 is negative 64. And this is 256. I think basically, you know, you throw the ball in the air, goes up, comes down. So we're saying it takes maybe at 2 seconds or 90 feet in the air. Now it says at what times will the ball be 240 feet from the ground? So now it's saying we're going to give you the height and you calculate the time. So I'm going to plug in 240 for S. And now solve this equation. This is a quadratic equation. Let me get everything on the left-hand side because I like this term to be a positive number. So I'll add 16t to both sides. I'll subtract 128t from both sides. Plus 240 equals 0. Now I have a hunch that maybe I have a common factor of 16. So I can divide all 3 of these by 16. 128 divided by 16 is 8. 240 divided by 16 is 15. This actually factors into t minus 5, t minus 3. Does it make sense to have 2 solutions? Well, say you throw the ball in the air, and right here is the 240 feet mark. Well, here's the amount of time on the way up. That would be like 3 seconds. Goes up, comes down. On the way down, it's once again at 240 feet above the ground. And that took 5 seconds. So yeah, it makes sense. All right, there are actually 2 more problems on the back here. And these are where you sort of have formulas. We call them formulas. So you have many variables. You're trying to solve for one of the variables in order to get one of the variables by itself. So A over B equals C plus D over D. And we're trying to get D by itself. First thing I'm going to do, I'm going to clear my fractions. I always do that. Just makes life a lot easier. What would my LCD be? Looks like BD. So I've got A over B equals C plus D over D. I'm going to multiply both sides by the common denominator. When you do that, the B's cancel out and you have AD equals, these D's cancel out. So now the fractions are gone. It's going to multiply out these parentheses, BC plus BD. Now, since I want to solve for D, I want to get everything with the D on one side. So let's subtract BD from both sides to move it over there with the other D. If I factor out the D, Now, if I want d by itself, how about I divide both sides by this fraction? And there you go. And the last one, solving for r, 1 over p equals 1 over q plus 1 over r. I'm going to clear fractions again. Lowest common denominator is going to be PQR. So multiply both sides by PQR. Left-hand side, the p's cancel out. QR, PQR times 1 over Q, the q's cancel out. You have PR. PQR times 1 over R, the R's cancel out. If I'm trying to solve for R, let's get the R's on the same side. So I'll subtract PR from both sides to move it to the left-hand side. Factor out the R. I'm going to get R by itself, divide both sides by that parenthesis. And there you go. All right, so those are the kinds of problems that you'll be seeing on the exam.